Okay, I think we can start now. So good afternoon, everybody. So as I told you before, we have different sources of interrupts. As you see here, we have different sources. I have already explained IRQ, RTI in chapter 5. I'm going to explain the timer system. The timer system has 9 interrupts, as you see here. Today, I'm going to explain, we have 2 interrupts here for serial communication. So the microcontroller, it has inside the microcontroller, there is 2 circuits. One circuit for SCI0, serial communication interface 0. Also, we have another one, SCI1, for serial communication interface number 1. Okay. First of all, what do you mean by serial communication? Very simple. Serial, as we had one example in the beginning of chapter 3 about serial communication. In serial communication, we have here microcontroller and another microcontroller. They can communicate together using serial data. So 10, 10, 10 this way. You can transmit data this way. Okay. By the way, SCI0, you are using SCI0. How do you use it? You are using it in order to enable your computer to communicate with the board. This is how the computer can communicate with the board using serial communication 0. Today, I'm going to explain how can you do serial communication 1. Is that okay? Also, I want to tell you something important here as well. Give me 1 second. So here, SCI1, if you look at the back here, back of the board, it's written SCI1 for this one. So that means if you have a board, you have another board, you can connect a cable. You can connect a cable from here to the other board so that the 2 boards can communicate using SCI1, using serial communication. Is that okay? Also, you can see we have here a location to put Zigbee. So what is Zigbee? Zigbee is a wireless module. It can be used to communicate using also SCI1. So you can use SCI1 serial communication in order to enable one board to communicate with another board using serial communication. Is that okay? So today I'm going to explain it how it works here. Let's see if I have it here. Yeah. So here, you know what I mean by serial communication. Serial communication is already used in many devices are using serial communication. The serial communication interference, that's what we call it, SCI, is used to transfer data using serial communication, and usually they use this standard asynchronous. So here, if you have some background in communication, this communication is asynchronous. Asynchronous means there is no clock. Okay, the clock of the transmitter and the receiver are not synchronized. That means both of them don't have the same clock. That's why in communication you need to use some techniques to achieve synchronization. Is that okay? So here also I wanna also I want to talk also about we have serial communication. Also we have parallel communication, data transfer communication. Okay. Usually for microcontrollers we didn't use parallel for several reasons. Number one, you know the idea of serial. In serial, you need only one pin. Okay, only one pin, and then you are going to send the data serial. Serial means 1, then 0, then 1, then 1, and so on. However, in case of parallel, you need more than wire. You need, for example, it can be 8 pins, and you can just output the byte at once. So I can put here 0, 1, 0 at once. Okay, for sure, this parallel is very fast. That's for sure, it's very fast. However, usually in microcontrollers, we don't use them usually. The main reason for that is actually most of the devices we are using don't need this very high or very fast communication. Okay. So for example, you can use serial communication for if you have a sensor, or so you don't need actually this very fast communication. Also, as I told you, you cannot connect too many devices. Why? Because as I explained right now, you need 8 pins for only one to connect only one device. That's why usually we like serial communication is more suitable for microcontrollers. Okay, that's what I'm gonna focus on right now. Okay, that's what I told you guys here. So you have here connector, you have a wire here, you can connect wire here, and you connect another wire in the other board in order to connect the microcontroller SCI1 here to SCI1 here, because there is a circuit here for interference here, another circuit here. Okay. So now I'm going to focus on how can you program it? How can you program this serial communication? So the first thing I want to talk about, we call it data format, how the data looks like. This is how the data looks like, guys. This is like a frame. In this frame, you have a start. You have a start bit. So this bit can indicate this is the beginning of the frame. And then after that, we have your data, which is 8 bits. So this is byte. This is a byte. You transmit a byte, bit by bit, and then you have a stop bit. Okay. So you have 1 bit to indicate this is the beginning. You have another bit to indicate this is the end of the frame, and then you have byte. Sometimes, that's what I'm telling you. Sometimes we have 8, and sometimes we have 9. In case of 9, actually, I want to transmit a byte. So here, this is a byte. Sometimes we have 1 more bit here, 1 more bit. This bit is called parity bit. I'm not sure if you are familiar what parity bit means, but I can say it quickly. Parity bit is used if you want to check for errors, for some errors. If you transmit data and error happens, so this can catch some errors, okay? So it just, this is your data is a byte. So I'm gonna add 1 more bit, okay? If this bit is 1, for example, just an example, that means the number of ones here are even. If it is 0, that means the number of ones are odd, okay? And after you receive the byte, you can check and see if this bit is consistent with the number of ones here or not. So this can catch some error. It cannot catch all errors, but it can catch some errors. For example, if this bit tells me the number of ones are even, but when I look here, I found the number of ones are odd. In this case, I have to make sure something is wrong. There is an error. Okay, anyway. So when I see here, guys, the serial communication can be used to transmit 8 or 9 bits. Okay. In case of 9 bits, you actually it's 8. It's a byte plus 1 bit for parity. Is that okay? So the way it works, the least significant bit is transmitted first. Okay, because it transmits bit by bit. So it started with the least significant bit, and the last one is actually the most significant bit. Okay. Now I'm going to explain. So again, very simple. The idea is very simple. Look here, guys. We have microcontroller. Inside the microcontroller here, there is a circuit. There is a circuit. Okay. This circuit should take care of the transfer. Okay, the serial transfer. I'm going to explain right now how can you program it. Okay, the first thing you have to program is the baud rate. Baud rate means the speed. What is the speed? How many bits you transmit per second? So this one is measured by bits per second. Is that okay? This is the speed. And for sure, the two microcontrollers, the transmitter and the receiver, both of them should have the same speed. Is that okay? So this is something you can program. So as shown here in this table, I can have, this is a baud rate. This is the baud rate I can get. So as you see here, I can have many different values here for the baud rate. So I can get different values. So the question is, or what I'm gonna answer right now, you can program, you can configure. So you can configure the interference the interface, sorry, the interface, you can configure the interface to work on a certain bot rate. Again, what's really important here, the transmitter and receiver, both of them should have the same bot rate, okay? So there is a formula, as you see here, this is the formula. This formula is telling you, this is the bot rate you want to get, okay? This is the clock, this is the system clock, which is 24 megahertz. Okay, 24 megahertz, that's what we use all the time. Here in this table, I give you also in case you use 16 megahertz, but in all the time in this course, we use 24 megahertz. Okay, so if you do this division, you are gonna get a number. This number you call it SPR. This number you have to write it in a register. That's it. And so again, and I got all the numbers, I put them in the table here. So if you look at this table here, guys, in case if you 24 megahertz, so you put here 24 megahertz, okay? If you want 5,000 bot rate, so this is the number. This is the number you have to put in this register. Very simple, right? So all what you have to do, guys, number one, you have to decide in order to, this is a configuration, similar to the configuration we did before for RTI, similar to the configuration we did for IRQ, this is also configuration. After you decide what bot rate you want to use, you have to write the number, this number actually, it needs up to 13 bits. If you look here is the biggest number, all what we need up to 13 bits. That's why if you look here, we are going to use two registers. This is one register, SCCI0 BDH or SCCI1 BDH. It's two registers, by the way, because as I told you, we have two serial communication. We have number 0 and number 1. Please don't use number 0 because number 0 we use it to connect your computer to the board. So here you have to use this one in order to program SCCI1, right? So what happens here, guys, as you see, we have two registers. One register here, we call it SCCI1 BDH. We have another one here, SCCI1 BDL, okay? And now, again, as I told you, based on the number, the biggest number here we have here, all that I need only 13 bits. I don't need more than 13 bits. So that's why, as you see here, I'm gonna take these 8 bits and then I'm going to take here 5 bits from here, as you see here. So this is bit 0, bit 1, bit 2, bit 3, bit 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that okay, guys? So again, in order to configure the bot rate, all what you have to do, number one, you have to select what bot rate you want to use. And then either if you want to plug in this formula in order to get the number you have to use, or you can just get it from the table here. You can get this number from the table here, and just all what you have to do, guys. You have to do move instruction. You have to do move instruction in order to write this number in these two. You have actually to write two move instruction. You have to write a part here and a part here, okay? Because this number it's going to be written in 2 different registers, as you see here. Is that okay? Is that easy? Any questions? So this is one thing you have to do in the configuration. Okay. For example, let me link. So this is a program I'm going to teach right now. Okay. So this is what I did here. Yeah. Look here, guys. Yeah, here and here in 2 registers. For example, I wanna bot rate of 9,600. So in this case, it has to be 156. So here in one register, I'm going to write 156 in one register in decimal, and the other one for sure has to be 0 because 156 it's enough to be in 1 byte. So other byte I put 0. That's what I did here. Very easy, right? So this in order to configure the bot rate. Okay. So if you go to the table, what is the table? 996. Yeah. So I think I made a mistake. I'm sorry. I switched it. This is the bot rate. I'm sorry. This is the bot rate, and this is SCPR. SCPR. This is the number you have to use. This is the bot rate. I think I switched it. I'm sorry for that. Okay. So if you see here, guys, for example, I wanna get this bot rate 9,600, and this is our clock, not this one. We're not using 16. Okay. So if you come here, so this is the number you have to put in this register because this number is less than 255 55. So it is enough to put it in one register. The other register, I'm going to put 0. That's it. That's exactly what I did right now. In order to make the baud rate 9600, I have to do the same thing on the other port. Both of them should have the same baud rate. Any questions? Great. What other configuration you have to do in order to be able to use the serial communication? We have here this bit, guys, in this register. Again, you can see, guys, every register, we have 2 of them in every register. One for interference, for serial communication 0, and one for 1, because as I said, we have 2. We have 2 interfaces. Okay, so now we are going to use 1, as I told you. So we have here 1 bit number 4. This bit number 4 can tell, do you want one start bit and one stop bit? Do you want to have 8 data bits or 9 data bits? I told you can select 8 data bit or 9 data bits. The only difference between them, we add 1 more bit. In both cases, I'm gonna transmit byte in both cases, but this one has 1 more bit for the parity. Is that okay? So very simple. So if I put here 0, what it means? It means, okay, I want to use 8 bits. If you put here 1, it means I want to use 9 bits. So I'm going to choose a configuration. How? Very simple. How can I do this in the configuration? Yeah, that's it here. That's what I did here. Yeah. So just I put 0 in this register because I want to select 8 data bits. Is that okay, guys? Okay. What else do you have here? As you see here, guys, in this register, SCCI, CR2. This one is CR1. Okay. In this one, we have here, we have this bit. This bit is actually receiver interrupt enable bit, because the idea is that if I receive a data, how I can know if I received the data? Okay, should I do polling? Right. For example, I have 1 bit. I have to check. Have you received the data? No. So I can do some kind of polling. But we agreed before, polling may not be a good idea. So what's going to happen is that, okay, microcontroller doesn't need to do anything. Once the serial communication receives, once SCCI receives a byte, it's going to make interrupt to come and take the byte. That's it. Okay. So we have here interrupt related to the receiver. Okay. And this interrupt, if you go to the table, you will find here in this table all the information about this interrupt. Yeah. So here, guys. So here for the interrupt here, this is the number you have to use as we did before. So this is the number you have to use is here. Again, you should understand why we need interrupt here, guys. Simply because if I want to know if I received the data or not, what should I do? Number one, you can do polling, which for sure waste of time, or you can just interrupt. Okay, so once the data is received, the serial communication is going to trigger interrupt. That's it. And then inside the interrupt subroutine, you have to read the data. That's it. Okay. So like any other interrupt I explained before, for any interrupt, I have to tell you where is the enable bit. I have to tell you where is the flag bit, right? As I told you before. So here, this bit, I was explaining here, this bit. Yeah. So this bit, actually, this bit is the enable bit. That means if you want to enable interrupts, receiver interrupts, simply you have to put 1 here. That's okay. You have to put 1 here. Okay. Also here, this one, receiver enable. Do you want to enable receiver or not? For sure, if you want to use the receiver, you have to enable it. Transmitter enable bit. Do you want to use the transmitter or not? So if you want to use, by the way, this is the same microcontroller can transmit and receive at the same time. So here in every microcontroller, we have here transmitter, we have receiver, and we have transmitter. We have receiver and transmitter circuit for transmitter and receiver. Okay, so that means you can transmit and receive at the same time. So what I'm saying here, guys, simply number one, if you want to trigger interrupts for receiver, simply you have to put 1 here. Simply, if you want to use the receiver, you have to put 1 here. If you want to enable the transmitter, you have to put 1 here. If you put 0 here, so the transmitter is disabled. You cannot transmit. Same thing here. If you put here 0, receiver is not in it. So what I want to see here, guys, if the way you have to configure this one, I have to put here 1 1 and 1 1 here. So this actually, and you can put 0 everywhere else. Okay, we don't need them. So actually, this is 2C. And that's exactly what I did right now. Very easy. All what you have to do, you have to come up with a number and you have to write it to the register. That's it. That's it. That's exactly what I did. So if you look at the configuration here, that's what I did here in the first one here. So what I did in the first one, I'm gonna write 2C here. Also, I'm gonna do this one similar to what to do for any interrupt source. I have to do org. I have to use the correct number. This is the subroutine for interrupt source. Okay, guys. That's all the configuration we have. That's it. So for again, I'm gonna repeat it again for configuration, guys. You have to do this one. This one should you should enable transmit and receiver plus you should enable interrupts, receiver interrupts. Okay, this is one for these two. Okay, for the baud rate. This one to tell I wanna do you wanna select 8 data bits or 9 data bits? Is that okay? So that's it. Once you do this one, okay, so you are now ready. It is ready to use it now. The serial communication is ready. So what other register I may need? One of the okay. Now I told you what if I wanna transmit or I receive? Okay, for example, I'm gonna tell you what is the idea. The idea is that we have a register here, guys. This register is called SCCI X. What X means? X can be 0 or 1, as I told you before. Because we have two, one for serial communication, 0 and 1. Again, we're going to use 1 all the time because 0 is going to be used by the code warrior. Okay. So anyway, I just want to tell you how it is easy. So what I'm going to do right now is, guys, this one, after you receive a byte and you already have a byte here, okay, interrupt automatically is triggered. So once you have a data to read, interrupt is triggered. So all what you have to do in the interrupt subroutine, you have to read this register. That's it. So if you wanna, so every time a byte is received, interrupt is triggered. Okay. In the interrupt subroutine, I'm gonna read this register. Is that okay? To get the byte I received. Okay. Same thing if you wanna transmit. If you wanna transmit, you have to write to this register. Is that okay? So actually, although this register is only one register, but actually inside it, it's like two registers using the same name. How do you say 2 registers? Yes, that's because we can transmit and receive at the same time. So it's actually, it is one name, but every time you want to write, I'm going to write here. Every time you want to read, I'm going to read from here. You got what I'm saying? Because one of them is receiving, the other one is only transmitting. So very simple, very simple. If a microcontroller receives a byte and you want to read the byte, how can you read the byte? I'm going to read the byte from this register. That's it. I'm going to read byte for this. Same thing, if I want to transmit a byte, how can you transmit a byte? You have to write it to this register. That's it. But also keep in mind, it's only one name, but inside it, actually, it's 2 registers. It's not only one. So inside it, there are 2 registers, one connected to receive, one connected to transmit, right? Both of them have the same name. However, when I read, I'm going to read from here. If I write, I'm going to write to here. You understand the idea, guys? It's not only one. It's actually 2 registers, but both of them have the same name. When I read, I'm going to read from the one. When I write, I'm going to write to the other one. Okay, guys, any questions? So very easy. So if number one, how can you know I received a byte or not? Very easy, interrupt. So once I have interrupt, that means there is a byte read it for me. I have to read it. How can you read? I'm going to read it from here. That's it. If you want to transmit, how can you transmit? In order to transmit, all what I have to do, just I have to write. I have to write this one here. However, I have to make sure this register is empty before I write a new value. For example, look here, guys. I told you, this is the transmitter is here. I already give it some value, like 3A to transmit. I should not write a new value until I make sure this one is done. This transmission of this one is done. You understand what I'm saying? So number one, I'm going to write a value, and then I have to wait until make sure this value is transmitted, and then I can give another value. How can you do that? Very simple. You can do that using this bit. So you have a bit here. This bit is called transmit data register empty flag. So this register can tell you, this bit can tell you if the receiver is empty or not. Is that okay? So once you write something, this one is going to be 0. Once you finish, once it's a serial communication, transmit the whole byte, and now it's empty. Now you can write again, just to put 1 here. And that's what I'm gonna show you. So now I'm gonna show how can you use both of them. So here, let's see what I'm gonna do here in this example, guys. In this example, I'm gonna connect to 2 boards. So this board and this board. I'm gonna connect to 2 boards together, okay, using cable here, okay. And then what I wanna do here, when I write, for example, when I press number 5 here, I wanna see it on the LCD of the other one. So this is similar to lab, the last lab we did, but now I'm gonna do it using 2 boards, not for the same board. So when I type here, when I press 5 here, I want to see 5 on the other one. Is that okay? When I press 7, I want to see 7 on the other LCD. Okay. On the same time, in the same time, I can do the same thing here. If I press 5 here, so both of them are gonna work at the same time. If I use any keypad, if I write something on the keypad, it has to be shown on the other LCD. You got what I'm saying? Also, I'm gonna use asterisk. This one is star or asterisk. I'm gonna use it to clear. That's it. I make it simple. So this is similar to last lab, but instead I'm gonna use only one special character. In last lab we used almost all of them. You can move the cursor. You can do a lot of things. You got what I'm saying? So here you just use asterisk. Is that okay? So again, if I press here asterisk here, what we did in the last lab, we cleared this LCD. But what I'm doing right now, when you press asterisk, I'm going to transmit to here, and this microcontroller has to clear this LCD. Is that clear? Is that okay? Clear, guys? Okay. Let's see how we will do it this way. Okay. So number 1, again, because I'm using the keypad, so I have to configure register A. I have to call this one for the LCD to configure the LCD, okay, and then now I'm gonna what I'm gonna do the transmitter in the main program. So this is the main program. I'm gonna do the transmitter part here. So every board can transmit and receive, right? So here this is the transmitter part here, and then I'm gonna use interrupt for the receiver. The same program, this program, I have to run it on the 2 boards. The same program should be run in the 2 boards. So the way it works, guys, as you see here, if I want to transmit, how I can transmit, as I told you, very simple. All what you have to do, the byte you want to transmit, you have to write it to this register. That's it. So if whatever you want to transmit, you have to write to this one. However, before you write to this register, you have to make sure this one is 0. That means it's empty. I finished the last value, and now I'm ready to transmit a new value. How can you do that? That's what I did here, as you see here, guys. So I'm gonna check this bit, and then as long as this bit is 0, that means it's empty. Okay. So here I'm gonna check it. As long as it is 0, that means it's not empty. So I'm gonna keep looping here until it is 1. Okay. So again here, if this one is 0, that means the register is not empty. That means the microcontroller is still transmitting the value you sent last time, right? So anyway, so I'm gonna keep looping here. I'm gonna wait until you finish transmission. After you finish transmission, I'm gonna call the keypad to get a number from you, and then the number I'm gonna get from here, I'm gonna write to this register. That's it, to transmit it. Very simple. Then I'm gonna go back. I'm gonna wait again until it is empty, and then I'm gonna write. That's it. So as you see here, it's just 2 steps. The first step, I have to make sure the buffer is empty. That means already everything you wrote to the buffer has been transmitted, and now it's empty. And then after that, I'm gonna take one number. I'm gonna write it to this register. That's it. Okay, guys. So this part is gonna be executed on the 2 boards, so that this one can transmit this one can transmit this one. Is that okay, guys? Any questions? Now let's look at the receiver. In the receiver, as I told you, I'm going to use interrupts. That means for the receiver part, I don't need to check. Did I receive anything? No. Did you receive anything? No. You don't need to do pooling. because this is waste of time, as I said before. Okay, so all what I'm gonna do right now, guys, as you see right now, once this interrupt is triggered, that means there is data already. I received the data and it's ready for you. Go and take it. Is that okay, guys? So once this interrupt is triggered, this is the event. You remember the first thing, the first word I used when I want to define interrupt is I said event. There is an event and we have to respond to the event, right? The event now is receiving a byte. We received a byte. This is the event, right? So all what you have to do, guys, now, after you receive a byte, I told you the byte you are receiving should be in this register. Okay, just read and then do whatever you want. That's what I'm gonna do right now. So here I'm gonna read this register. As you see here, I'm gonna read this register. This is the byte I received from the other board, and now I'm gonna compare it to asterisk, because I told you if you press an asterisk, so I have to clear. So I'm gonna compare it to asterisk. If it is not equal, that means I'm gonna call boot character LCD. So I'm gonna display it. I'm assuming what I'm gonna receive from the other side, either a number from 0 to 9 or asterisk. So if it is not asterisk, so it should be a number from 0 to 9, and I have to display the number. So if you send me a number, I'm gonna call this one to display. However, if you send me asterisk, I'm gonna come to this way to clear LCD. So here, if clear LCD, I'm gonna come here to display number. That's it. Is that okay, guys? Very easy. Very easy. So all what you have to do, every time this one is interrupted, you don't need to think, have I received anything? No, because once you are here, once the interrupt is triggered, that means you already received something, and just as a hardware is telling you, just take it. I already received something, just come and take it. So that's why I'm taking it here. I'm taking it. Okay. So after I take it, as you see here, now I'm gonna check if this is asterisk, so I have to clear LCD. Otherwise, if it is a number from 0 to 9, just to call boot character LCD. Any questions? One thing is missing. One important thing is missing. Always you have to clear the flag bit. Always you have to clear the flag bit. Okay. One way to clear the flag bit by reading register. Sometimes I already explained it before. In case of timer, RTI, how can you clear the flag bit? Okay, there is a register and you have to write one to this register. Sometimes, if you want to clear a register, if you want to clear the flag bit, you have to read the register. And that's exactly what happens here. So here I'm reading the register, not because I want to read the register, because once I read this register, the interrupt flag bit is going to be cleared automatically just by reading, right? So this is, which register is that? This is SR1. Yeah, this one. Okay. So here, this is a receiver. This is a flag. This one here. This is a flag register. So again, if you can write one, if you want, you can write one here in order to clear it. Or the other way you can do it, just read the register. Once you read the register, automatically it's going to clear it. Okay. That's why I did here. Okay. So here I just read the register because this is one way to clear the flag bit. Okay. Very important, as I mentioned many times. Very important. Please, if you do your capstone or if you do any project, don't forget you have to clear the flag bit. Don't forget it. Okay. And we did it. We did it right now. We did it in RTI, and the only exception was IRQ. I don't need to do it in IRQ. Okay. I'm gonna do it in the timer shortly. Any question, guys? Great. So how can we do the same thing in C language? Okay, very easy. In C language, we just have programs. Sorry, we have functions. We can just use the functions. So let's see what functions we have. We have this function SCI1 initialization. Okay, so this function is going to do initialization, and all what you have to do, just send me the baud rate here. That's it. Just give me the baud rate, and this function is going to do everything. So actually, if you open this function and you see what is inside this function, you will find all of these are here. All this instruction, I wrote it here. We just put it in a function, okay? And this function is going to see what numbers based on the baud rate you are sending to the function. It's going to see what number you have. It has to use here, okay? Just to give me the baud rate, and then Then this function, inside this function, is going to see, based on this baud rate, is going to take the number, see which number it has to use for this equation. Okay. That's it. Very simple. That's it. Just one thing. Okay. That's it. And now this is inside in the main program. All what I'm going to do, as you see here, I'm going to get a number. I'm going to get a number from the user using get key. And then I'm going to convert it to ASCII. And then if you want to transmit anything, you have to call a function. This function is called output character 1. This function. It's called output character 1 and send C. That's it. Okay. So again, if you see what is inside this function, you will see it's similar to what I did here. Inside this function, something like that. It has to wait. It has to wait until it is empty, and then it has to transmit it by writing this one to here. Is that okay? For the interrupt subroutine, similar to what we did before, you have to use the word void. You have to use the word interrupt. You have to use the number. You remember the number we used to before, number 6 and number 7 for IRQ RTI. This is number 4. If you go to the table, if you remember, because okay, so this number can tell the C language which interrupt it is this one. Okay. Yeah. So as I told you, this is number 1, number 2, number 3, 4, 5, 6, 7, 8, 9, 10. If you go all the way, you'll find this one, SCCI, this one should be 21. 21. Okay. This is exactly similar. And this is exactly what I'm going to do also with the timer system. When I talk about timer system, it's exactly the same thing. That's why in the very beginning of interrupts, I told you, if you learn how can you program one interrupt, all of them is the same. You just change the numbers. Okay. So now, here I have to select number 21 because this is for SCCI1, 21. Okay. And then this is inside here. So what I'm going to do here, guys, all what I have to read. So you have to read using, you have to call this function in order to read the byte you received. Okay. So again, this interrupt is triggered when you receive a byte. So once I receive a byte, I want to read it. After I read it, I'm going to convert it to ASCII. Okay, here. Then after I convert to ASCII, I'm going to compare it asterisk, similar to what I did before. I'm going to see if this one is asterisk or not. If it is asterisk, so I have to clear. Otherwise, this is an instruction to clear, right? And this one, otherwise, I'm going to write it. I'm going to write this character on the LCD. Is that okay, guys? Any questions? Very easy. So again, just to summarize what I said, in C language, for initialization, you have to use this function, number 1. Number 2, if you want to transmit, you have to use this function, very easy. Number 3, if you want to read one value here in the interrupt subroutine, you have to use this function, only 3 functions. Also, don't forget this 21, because this 21 is telling the C language, this interrupt is for SCCI1. Any questions? Great. So now I finished chapter 4. In chapter I also finished I think chapter 3. I just have 3 functions I didn't teach in chapter 3. I want to finish. I want to explain these functions, just very few functions. After that, I'm going to start chapter 5. Okay. So here, the first function I want to teach here is, last time I explained how can you convert. Okay, let me. Okay, look here, guys. In in assembly, we have a function in assembly. In assembly, we have a function. This function is called keypad. So keypad is going to give you only one keystroke, one number. So this one is going to give you only one number. Is that okay, guys? Okay. What if I need to get multiple numbers, not only one number? Okay. So you can use the keypad multiple times. For example, I can ask the user, please enter a number, and when you are done, press enter. And enter can be like any any special, any key here. For example, the key that has this ASCII. You understand what I'm saying? So now, what if I want to read more than one number? For example, I want to get from the user 3725, and then after, when you are done, press this one, or like enter. So this one, something like enter when you are done, right? So something like enter. How can you do that? Very simple. All what I'm gonna do, I have to call this function multiple times to do that. Okay. All what I did, I just emit a function. You can just use this function that can. So this one is going to give you only one number. If you need more than one number, I have a function. You can just use it. As you will see right now, inside this function, I'm using this function. As I said, this function, I'm going to use it. I'm going to call it multiple times until you input this enter. That's what you can just, if in exams or anything, you can just use this function. So this function is called get number, as you see here, get number. Okay. So this function, what's going to happen here in this function is going to get numbers from the user until the user hit a special character, which is this one. So this is, I'm going to call this one enter. Okay, which is this key, the second key here. Okay. So after you enter a number, and if you press this one, that means I am done. Right. So what this function has to do is, every time before you call this function, you have to give the beginning address of an array, because this function is going to take numbers, is gonna push them in an array. So that's why before you call this function, you have to put the beginning of the array. You want to fill, you want to store the numbers you are going to get from the user. You are going to put them in the array. You have to put the beginning address in register Y before you call this function. What's going to happen? This function is going to take a number from the user, and then it's going to put the ASCII here. So this function is going to store the ASCII numbers it gets from the user in an array. For example, you enter 0, so I'm going to store 30 ASCII in hexadecimal, 37, 39, and so on. 38, 39, and at the end is going to put 0 as a delimiter. It's going to put 0 at the end as a delimiter. Automatically, the function will do that. Okay, guys. So again, we have a function. All what you have to do before you call this function, you have to store the beginning address of an array in Y, because this function is going to get numbers from the user until the user hit enter, and this one is going to put numbers this way, and then it's going to put 0 here. Okay, guys. I'm going to tell you now, I'm going to teach now 4 functions. The good thing about these functions, they are compatible. What do you mean by compatible? It means you can get the output of this function, you can input it to another function to make programming easier. By the way, I already taught one function before, if you remember, put string to LCD, right? And I told you, if you want to call this function, put string to LCD, all what you have to do is that you have to give, number one, you have to put 0 delimiter. So you have to put 0 delimiter at the end, right? So, and then you have to put the ASCII of the message you want to display, and you have to put 0 at the end, and you have to put the beginning in register X before you call this function. Okay, so what I did right now, guys, the output of this function is compatible with this function. How? I'm going to tell you how. Look how. So all what you have to do, guys, number one, this is an array. You have to put the beginning address in register Y before you call this function. That's okay. This function is going to take numbers from the user. It's going to store them this way. And the delimiter here is 0, similar to put string to LCD. Okay. After you get a number from the user, if you want to display the number, how can you display it? You can call this function. However, this function is expecting the beginning address in register X. So you have to put the beginning address of this array. You have to put it in X and then call this function. Look how it is compatible. So number one, if you want to get more than one number from the user, you have to call this function. After you call this function, you can call this function to display it. Okay. So I'm going to explain how this function works, guys. It's very simple. All what I'm going to do, as I told you, I'm going to keep calling. I'm going to keep calling keypad until you hit enter. Once you hit enter, I'm done. Right. So what's going to happen here, as you see here I'm assuming we accept negative numbers. negative number. If the number is negative, so I'm going to put the ASCII of negative here. For example, if it is negative 33.7, but here I'm going to put the ASCII of negative. That's why, as you see here, guys, number one, I'm going to call keypad. That's number one. Number two, I'm assuming here asterisk means negative. Then I'm going to compare to asterisk. I'm assuming the asterisk is negative. Okay. If it is negative, so I'm going to come. If it is negative, so I'm going to come to negative. In case of negative, I'm going to store negative, the ASCII of negative in the array. Is that okay? And then increment y. Okay. And then go to beginning again. Okay. This is number one. If not, so if it is negative, I'm going to come here to store the ASCII of negative. Okay. If it is enter, so if it is not negative, so I'm going to come to check now. Is this enter? If it is enter means you are done. So I have to go to here, enter. When I come to enter here, I'm going to store 0. I'm going to store 0 because this is the delimiter, because I am done. I'm done. So I'm going to put the delimiter here. Then I'm going to leave. I'm done. Is that okay? If it is not negative, if it is not enter, so I'm going to come to here. All what I'm going to here, I'm going to do, I just want to make sure the number is between 0 and 9. So what I check, I just want to check. As you see here, guys, I'm gonna compare to 30. If the number is less than 30, if the number is less than 30, it means it's a wrong number. So I'm not gonna store it. So please go to beginning again to get another number. If the number is less than 30, it's a wrong number. Okay. If not, if the number is greater than 30, now I'm gonna compare it to 39. If the number is bigger, higher than 39, that means the number is wrong. I'm not gonna store it in the array. Please come here, right? If it comes to here, what it means? It means the number is between 30 and 39. It's a correct number. So now I'm going to store it. As you see here, I'm going to store it, right? Very simple. So again, guys, this is an array. This array is going to keep calling. This one is going to keep calling keypad and then fill up. It's going to fill up array this way until you hit enter. It's going to put a delimiter 0, right? Any questions? Again, so now conclusion. Now there are two functions. You should understand them. This function get number. You should understand before you call this function, you have to put the beginning address of the array in y. Okay, and then this function is going to take several numbers from the user. It's going to store the ASCII here at the end. It's going to put 0 at the end. Okay. We have another one compatible with this one. This other one is put string to LCD. Put string to LCD. In put string LCD, all what you have to do, you have to store the beginning address in register X before you call this one. Once you call this one, you can see the number on the LCD. Is that okay? That's why it's compatible. So now I can get a number from the user, and then I can call this function to get a number, and then I can send this array to put string LCD in order to see this number on the LCD. Okay, guys. Now I'm going to teach two more set of functions. Okay. Also, it's going to make programming much easier. Okay. Last time, if you remember, I told you how can you convert binary to decimal and decimal to binary. Okay. As I explained last time, for example, if you have 3, that's what I explained last time. If you have a number in binary, you have to keep dividing by 10, right? So you have to keep dividing by 10 this way. Is that okay? Now, I made a function in assembly just to make it easy. So you can divide it by 10, and you can store the result in an array in ASCII. So now I have a function. All what you have to do, you have to send a number in register B or register D if it's 16-bit, register B and D, and this function is going to do this division, and it's going to store the result in ASCII in an array, okay? And it's going to put a delimiter 0 at the end. You got what I'm saying? So just to make things easier, right? Same thing here. If you wanna, how can you convert a decimal to binary? So this function, for example, if you have 37, 32, 35, something like that, or 35, 32, and then 0. So if you have something like, if you have an array like this one, you can send it to one function. I'm going to explain right now. And this function is going to convert it to binary. Okay, so it should be 5. Sorry, make it 2. So 2 to 5. So it's gonna make converted to a byte 2 to 5, or it can be a word, as I'm gonna explain right now. So what I'm saying right now, I just want to make everything easy. So how can you make things easier? And that's what actually most of the usually we do that in programming. C language comes with a big library. There is a library comes with Python and the C language. You can just use functions there just to make everything easy. Same thing, I'm doing it right now. So instead of doing the details, everything, no, we can make some functions. That's what. So now the first function I want to, actually, there are 4 functions. Okay, I'm going to tell you what are the difference between them. So this function should convert decimal to binary. Is that okay? So there should be a decimal number, like for example, 32, 30, 30, and then at the end it has to be a delimiter 0. And by the way, that's why I made this function compatible. This function may come from get number. Okay, so that's what I'm going to do right now in a program. I'm going to show how all these functions can be compatible. So number 1, you can call get number. After you call get number, you get decimal numbers. After that, I want to convert them to binary to do some operations on them, right? How can you do them? You can call any of these functions, as you will see right now. You have to send the beginning address in register Y. So I have to send the beginning address in register Y, and this one is going to take this number. They are going to convert ASCII to decimal, and then after that they are going to convert it to binary by multiplying by 10, as I explained before. So now the question, why you have 4 functions? I have 4 because we have 2 for 8 bits, 2 for 16 bits. The 2 for 8 bits, this function should return the binary number in register B. These 2 should return in register D. So all these functions, you have to send an array like this one. The beginning address has to be in register Y. This function is going to convert it to binary, and the return value of it, if you call 8 bits, is going to be in this one. If you call 16 bits, should be in this one. Is that okay? Also, you have 2 functions, one signed and one unsigned. Unsigned in case you may have negative in the beginning. You got what I'm saying? For example, negative 21. So it should be negative, the ASCII of negative, the ASCII of 2, the ASCII of 1, if you have something like that. Okay. So as you see, that's why we have 4 functions. So we have 2 functions if your number is 8 bits. We have 2 functions if your number is 16 bits. You have for each one of them, you have signed or unsigned. It depends on do you consider the number signed or unsigned. Okay, is there a possibility to have negative here, or it's just unsigned numbers? Okay, guys. So again, that's very easy. All what you have to do, you just have here 37, 32, and then 0, something like that. The beginning address, you have to put it in register Y, and then you have to call one of these functions. These functions are going to convert this decimal number to a binary, store it in register B or register G. That's it. You got what I'm saying? So again, same thing here. This one should do the opposite. What do you mean by the opposite? This one is going to take register B or register G. We have 2 functions, as you see here, for 8 bits or 16 bits. Okay. Anyway, and this one is going to divide by 10 to convert these numbers, this binary number to ASCII. So once you have a number here, for example, you have a number 255, for example, after you call these functions, you are going to have an array. This array should have 32, 35, 35, and then 0 at the end. Okay, and that's why before you call this function, you have to give me the beginning address where I have to store these ones. Okay, guys. So again, in this function, you have to give me a binary number. These functions are going to convert to decimal and then to ASCII, and then it's going to put them in an array. Okay, guys. That's why, as you see here, you have, so the input, what you have to send this function should be in register B or register G, 8 or 16 bits. Also, you have to send the beginning address in register Y. Okay, guys. So now let me tell you, I'm going to show one program, and that's it. I just want to show how things can be easy now if you do it this way. Okay. So now let me summarize what I said. Number one, guys, I have it's mainly four functions. Okay. So let me choose a program here. In this program, I wanted let me see if I have a video for this program here. Add numbers. I think I have one. Let me see. Because this is the last one. Yeah, look here. Look, guys, here. So now I'm going to input a number more than one digit. I just want to make addition calculator, like a calculator. So here I press 1. Let's see. Yeah, so here, as you see here, guys, I press 11 and then enter. This is the first number. Then I want to add it to 22, I guess. Then I press enter, as you see every time, because here I'm calling get number. When you call get number, I have to press I have to press multiple times, and then you have to press enter after that. Okay. So now, as you see here on the screen, yeah, look here, 11 plus 22 is 33. Is that okay? So I'm going to show it's usually in any programming language, it's something very easy to do, but here it's too complicated, very complicated. It's low level. You got what I'm saying? You are going to get digit by digit. You have to convert ASCII to decimal. You have to convert to binary, and then you have to add binary to binary. Okay, but I tried to make it easy by using functions. Yes. Here I'm assuming byte to byte. We are adding byte to byte. Byte. So yeah, based on the functions I have, it can be a word or a byte. Overflow. Yeah. So again, if your program does not catch overflow, you are going to get a wrong number here. So for example, you are going to add 200 plus 100, the result is 50. You got what I'm saying? But if you catch for overflow, you can say, should say there is an overflow. Okay. So I'm going to show you how the program, it's how I made it using the functions I told you. Functions made everything much easier. Okay. As you would, oops. Okay. Hopefully. Okay. Look, guys, number one, I need to get one number from the user. Is that right? How can you get a number from the user? As you see here, guys, I created an array. This array should have five locations. I'm assuming you should not enter more than 5. Is that okay? Okay. Maybe 5 is too much, but anyway, so I created array of 5 because I'm using here 8 bits. In case of 8 bits, the number should not have more than 3 digits, and we have 1 digit for 0 for the delimiter, so you don't need more than 4. That's okay. So here I created an array. And look here, guys. Number one, I want to get a number from the user, so I'm gonna call get number, right? But before you call get number, I have to send the beginning. This is the array I have to send the beginning address here, so that this get number is going to take numbers from the user, is going to put them here, and then it's going to put 0 at the end. Is that okay? That's exactly what happens. So after you call this one is going to get a number from the user, put 0 at the end. Okay. Next, after that, okay, I want to clear the LCD. Then after I get a number, and this number I store it here in ASCII. I want to display this number. How can you display this number? Put a string LCD. That's it. That's why here I'm calling put a string LCD, right? When you call put a string LCD, but the beginning address has to be in register X, right? So here this array, I'm gonna put the beginning address in X before I call this function. So now this one is going to get more than 1 digit from the user. This one is going to display them on the LCD. Is that okay? So if you in the video I enter 11. Okay. So now what this one is going to do is going to do here 31 and 0. This one is going to display 11. Now you can see 11. Is that okay? After that, I wanna convert this number to binary, because what's going to happen? I'm going to get two number. I have to convert this one to binary, and then I have to add binary to binary. Microcontroller can only understand binary. So in order to do the conversion, I did the conversion this way. Okay, so this one is going to do the conversion, and then it's going to convert and store the result in register B, as you see here. And then I'm going to store register B in number. So now I got one number from the user. I displayed the number. I converted to binary. I stored here in number. Is that okay? So I am done with one number. I have to repeat again with a second number. Then I have to add them together. Okay, that's exactly what I did. So, but before I continue, I'm going to display plus, so that after you enter 11 in the video, you can see plus. Now I'm going to repeat everything again in order to get a second number. So I'm going to call get number again to get a second number. I'm going to display it. That's why you can see 22. Okay, in the video, and then I'm going to display equal. Now I want to get the result. To display. How can you get the result? Before the second number you have here, you have to convert it to binary, right? That's what I did here. You have to convert the second number to binary. Now I have two binary numbers. One in number, this is the first one I got. The second one I got here in register B. So now I need to add these two binary numbers together. Now I have the result, which is 33, but binary. So I have to convert it to decimal in order to be able to display. And that's what I did here. So I have to convert binary to decimal. Now I converted to decimal, and now I have 33, 33, and 0. This is the result. I want to display the result. So that's why I have to call both string LCD. Okay, guys? Nothing is new. I just tried to make like function to make our life, or to make programming easier. That's it. Okay. And you know the details of this function. All the details are known. Okay, guys. Any questions? Okay. I think that's more than enough for chapter 3 and 4. So now I'm gonna start the chapter 5. For chapter 5, you will see right now, it's not very far from what I taught before. And for the final, don't worry, I'm gonna tell you exactly what I need. If I need anything from this chapter, I'm going to tell you what I need for the final. I know because this, unlike the other, so until now you have to study for the final from 1 to 4 completely, just for sure. Okay, but for chapter 5, I'm going to tell you exactly what we need here. I'm going to explain everything, but I'm going to tell you. So what chapter 5? Okay, so in the very beginning of this course, what chapter 5 is about? I'm going to tell you, and this is actually the beauty of microcontroller, as I'm going to show you what I mean now. Okay, guys, in the very beginning of this course, very beginning, in the first week, when I defined microcontroller, what I told you microcontroller is a complete system. So inside the microcontroller, we have microprocessor, and we have circuit for serial communication. We have circuit for RTI. Okay, we have circuit for timer system. That's what I'm going to explain here, the first part. We have another circuit for pulse width modulation. We have another circuit for analog to digital converter, and so on. That's why it's a complete system. You got what I'm saying? So what I'm going to explain right now, we have an external circuit here for timer system. Okay, this should enable us to do like complicated things. Okay, with a very little time for microcontroller, because it's the most important thing. How can you do complicated operation with a very little time from microcontroller? That's the most important thing. So that I need to take a very minimum or very small time for microcontroller, so that the microcontroller can do other things. Is that okay? So now I'm going to explain what is the timer system. And we are saying the timer system is going to do something complicated. Yes, it does. So tell us, what is this? You got what I'm saying? Again, it's complicated because microcontroller doesn't need to do the work. Most of the work is done by the external circuit, like the serial communication. The serial communication, as I explained right now, the microcontroller is going to do very minimum work, right? But most of the work is going to be done by the hardware to send the data serial. Okay, So anyway, so same thing for pulse width modulation. So let's start first with the timer system. What do you mean by the timer system? Is that okay? I'm going to tell you what I mean and how can you use it, everything. I'm going to give you more details right now. For the timer system, as you see here, guys, in this figure, number one, in the timer system, we have 8 channels, as you see here, guys. Channel 0, channel 1, channel 2, and until channel 7. We have 8 channels. I'm going to tell you what I mean by channel for sure. So we have 8 channels. Every channel has an external pin on port T. Every channel has an external pin on port T. Is that okay? Okay, give us more details. Every channel, you can program it to act or to work as input capture or output compare. Again, we have 80 channels. Every channel has a pin, external pin. Every channel can do one of two main tasks. One of two main tasks. One task, it can do input capture or output compare. One of them at a time. It cannot do both of them at the same time. It can't. But you can program it. You can program similar to what we did before. For example, you can program all of them input capture if you need too many input capture in your application, or you can program all of them output capture if you need all of them output capture in your application. You can program this one input, this one output, this one input, this one output, whatever you want. Is that okay, guys? Any questions? So I'm going to give you more details for sure. So now you are telling me this system has 80 channels. Every channel can act or can do input capture or output compare. You didn't explain yet what do you mean by input capture or output compare. Yes, I'm going to explain. Everyone has external pin. That's true. I didn't explain yet how we are going to use the external pin. I'm going to explain. Also, every channel of them can trigger interrupt. So you have here interrupt coming from channel 0, channel 1, channel 2. So now we have eight more interrupts. Every channel can trigger one interrupt. Is that okay? Okay, so now let me elaborate. On top of that, the system has what we call 16-bit counter. Only one. We have 80 channel, but we have only one counter, 16-bit counter. That's it. Now let me give you details. This is like a big picture. So the big picture, we know there is something you told us is something beautiful, something very interesting. We call it timer system. This timer system has 80 channels. Every channel can do input capture or output compare. Until now, we don't understand what is input capture, but this is something, it looks something good. Yeah, it's good. I'm going to give you details. Every channel has one pin, okay, external pin on port T. That's okay. Also, we have a counter. This counter is 16-bit counter. Also, every channel, every channel here can trigger one interrupt. So now we have 8 more interrupts. Okay, and even the counter itself, it can trigger what we call timer overflow interrupt. So now we have 9 interrupts. Now I'm going to give you more. This is a big picture. Now I'm going to give you the details. Is that okay, guys? Let's go to the details. I'm gonna start with the counter. You told us we have only one. Yes, we have only one counter. Okay, what this counter is doing? Okay, and for sure this counter should help input capture and output compare to do their work. That's true. Should help them. I'm going to explain how. Also, this counter should trigger what we call timer overflow interrupts. So let's start with this counter or timer, whatever you want to call it, timer or counter. Let's see how it works. What is the main idea? I'm going to tell you how it works. Look at the idea, guys, here. In the digital system, you should have taken something, we call it counter. There is some hardware circuit, you can design a counter. I'm sure in the digital system course, you have to design some kind of counters. So the idea of the counter is it's a logic circuit. The input of this logic circuit is a clock. There should be a clock input to the logic circuit, right? For every cycle, for every clock, this counter is going to be incremented by 1. That means it's now 0, 0, 0, 0, for example. After 1 clock, you should be C1. After a second clock, you should see number 2. Okay, it's counting. So every time 1 clock, you input 1 clock, it's going to increment the counter by 1. So that's exactly what we have right now. So we have here hardware counter. This counter should have a clock. And this counter should count. should count for every cycle is going to increment the count by 1. And because this counter is 16-bit counter, it has to count from 16-0 until 16-1. Make sense? Again, let me complete it like pieces. Let me finish piece by piece, and then I'm going to connect all of them together. Let's only focus on this piece. In this piece, guys, what I'm saying is we have a counter. This counter should count from, it has a clock. It has a clock, as you see here. The time, the cycle, this is a cycle. The time of each cycle is 1 over f. F is the frequency of this clock. That means this one is going to, every 1 over f, this is the time, is going to count from here to here. And then it's going to count it's going to be incremented by 1 every 1 over f. Makes sense, right? Because I told you for every cycle, the counter is incremented by 1. So if the time here is t, so for every time t, which is 1 over frequency, 1 over f, okay? So for every time t, the counter is incremented by 1, right? So, and then as you see here, what this counter is doing is just a part of the whole system. But let me finish it first. Just let's understand part by part, okay? So here what's happening here, this counter is counting, as you see here, counting 0, 1, 2, 3, until 1, 1, 1, 1. After 1, 1, 1, 1, 1, it's gonna go back to 0, 0 again and count all the way to 1, 1, 1, 1 again. And every time it rules from 1, 1, 1, 1 to 0, 0, 0, it's gonna trigger interrupt. We call it timer overflow interrupt. And that makes sense because so every time there is an overflow, it's gonna trigger one interrupt. We call it overflow interrupt. Is that okay, guys? Just to try to understand part by part, and then I'm gonna connect everything together. Okay. So any question here? So again, what I'm saying here, we have a counter. We have 16-bit counter, only one counter. This counter has a clock. For every cycle, it's gonna be incremented by 1. This counter should start from 0, 0, 0 and should end at 1, 1, 1, 1, as you see here. And then after 1, 1, 1, when one clock comes, it's gonna go to 0, 0 again and counting again. But this time is gonna trigger what we call overflow. And now I don't need to explain what it means, right? It's an English word because there is now overflow from 1, 1, 1 to 0, 0, 0. So every time there is an overflow, it's gonna trigger one interrupt. Any question, guys? Okay. So what I want to explain right now is you told us, I think everything is clear here, except only one part is missing now. You told us there is a clock here. There should be a clock here. And for every one cycle, the counter is going to be incremented by 1. So what is the clock here? What is the value of the clock? Okay, the value of this clock actually, guys, is so here, as you see here in this picture, guys, this is the system clock, which is 24 megahertz. This is what we call a system clock, 24 megahertz. All what I'm gonna do, I'm gonna divide this system clock, but by a value, we call it prescale. This is something you can program. I can program it, right? So I can divide this value by what we call a prescale in order to get the clock of the timer. You get what I'm saying? The clock of the timer. And again, for this clock, every cycle here, you increment the timer by 1. So how can you program prescale? I'm going to explain later in details, but for now, just to, for example, when the time comes, I'm going to tell you, we have a register, this register. So we have these 3 values. If you put 0, 0, the prescale is 1. That means the frequency, remember, the frequency should equal 24 megahertz divided by prescale. This is the frequency of the counter. This is the speed, how fast it can count. Okay, so here the prescale can take a value 1 up to 128. Okay, for sure this is the fastest, very fast. This is the slowest. Okay, so you can control it. It's up to you. Do you want the counter to count fast or slow? You can control it here, as I'm going to explain later in details. But for now, okay. Now this is what the timer is doing. So all what the timer is doing all the time, that's it. The timer is counting, as you see here, it's just counting from 0, 0, 0 until 1, 1, 1, 1. And then every time it rules from 1, 1 to 0, 0 should trigger interrupt. That's it. And then it should keep going. So it has to, again, from 0, 0, 0 until 1, 1, 1, and then trigger from 1, 1, 1 until 0, 0, trigger interrupt and so on. Is that okay? Great. Now, okay, until now I didn't explain how it is useful. We have a counter just counting, okay, and we can control the speed of counting. That's all what I explained. Now I'm gonna give you some details about input capture. What is input? I told you every channel I can use it to do input capture or to do output compare. Input capture is a task. Output compare also is a task. Okay, very important task. I'm gonna explain. So what is input capture? Input capture, okay, it's just a very simple thing. Input capture is used if you want to measure time. Input capture is used if you want to measure time. Input capture is used if you want to measure time. It's a very efficient way, very easy way to measure time. What do you mean by measure time? I'm going to tell you what I mean. For example, if I have a signal like this one, and I want to measure the time from here to here, okay? Who's going to help you to do that? Input capture. Very easy to measure this time from here to here. Also, if I have two signals this way and I want to measure the time from here to here, who's going to help you to do that? Input capture. Input capture is used to measure time efficiently in a very easy way. Same thing, if you have a signal like this one and I want to measure the time from here to here, who's going to help you? Input capture. Don't think about it. Every time you want to measure time of a signal, okay, input capture will do that. It can be, as I explained here, for using two different signals as you see here, or it can be the same signal as you see here. Okay, guys? Input capture, measure time. But you should ask me, why I need to measure time here? Why this one is useful? Why I want to measure time? Okay, just I'm gonna finish it quickly. Why? Okay, actually, I want to measure time because this is very useful in many applications. I'm going to give you only one application just to understand why sometimes I want to measure time quickly. I want to show you one application quickly, okay? For example, here, guys. Yeah, here in this, if you want to, the way there is a sensor, we call it ultrasonic sensor, As you see here, guys, this is the sensor is here, ultrasonic sensor, okay? This sensor has two parts, as you see here. One is transmitter and the other one is receiver. So this sensor is used in robot. If you have a robot and I want to measure the distance, how far is the wall or any obstacle or the wall, how far any is the wall from me, as you see here, guys. The transmitter should send signal, ultrasound, okay, and then it has to hit an object and then come back to the receiver. It has two parts, as you see here. So it has two parts. One is transmitter, so both of them should be connected to the microcontroller. If I want to measure a distance, how far is the wall, or how far is the nearest obstacle? So the way I'm gonna trigger the transmitter is gonna send a sound. The sound is gonna hit object and come back to me. Is that okay, guys? Okay, now how I can measure the distance? In order to measure the distance, all what you need to know the time. I want to know the time from here to here. How much time the signal took to go and come back to me, right? And then after you measure the time, you are going to divide this time by 2. Why you divide this time by 2? Because this is a time to go and come back, right? So the time from here to here is t divided by 2. Okay, and once you have the time, you can get the distance. How? Very easy. You know the velocity should equal the distance divided by time. Velocity is known because this is the velocity of the sound. It's a known value. This is the distance, this is unknown. I want to measure this one. So in order to get the distance, all what I need to get, just the time. You got what I'm saying? So I need to measure the time from here to here. So how can you measure this time? It's the time for the signal to go and come back. How can you do it? I'm going to tell you how. Look here, guys. I almost finished, but just I want to finish this part. So what happens here, guys, is that I told you for this sensor, in this sensor we have transmitter and we have receiver. So this is transmitter and receiver. All what you have to do, if you wanna do measurement, you have to generate a pulse here on the transmitter, as you see here. So once I generate a pulse, this one to the transmitter, you are triggering the transmitter. You are telling the transmitter, please, transmitter, send the signal. Once the transmitter sent a signal, this pin becomes high, as you see here. So once I generate this pin on the transmitter, this is a transmitter, right? So it's gonna transmit a sound. Once the sound is transmitted, the receiver should be high. Okay. So this is at this moment we transmitted a signal. When we receive the signal, when the transmitter receives the signal, it's gonna pull it low. So the time from here to here, the time from here to here is the time for the signal to go and come back. So who's gonna help you to measure the time from here to here? Input capture. Input capture. Okay, conclusion, I already, that's more than enough. What I want to see here, guys, number one, input capture is used to measure the time. If you have a signal like this one, it's going to be measured, very easy way to measure the time, okay? And in this example, I'm giving you example, okay, how, in what application I may need to measure a time. So I give you example here, because after you measure this time is the equivalent to the time for the signal to go and come back. So I'm going to divide this 1 by 2, and then I use it in an equation to calculate the distance. Okay. So in many cases, this is just one application. In many applications, guys, I have a signal. I want to measure the time from here to here. I have a signal, something that I want to measure the time from here to here. Or sometimes I have two signals. I want to measure the time difference. I want to measure the time. And this time, I'm going to use it. It means something similar to what when I measure the time from here. It means this time. It means the time from the signal to go and come back, and I can use this time to measure distance. So who's going to help you to measure any time for like in any one of these cases? Input capture. Okay. So I'm going to continue next time, but for now you should understand input capture is used if you want to measure the time. Okay, guys.